Hi, I'm Dave Perellis, an engineer at Tektronix. This is our second video in the XYZ series on how to trigger an oscilloscope. In this video, I'm going to use a TBS 2000 series oscilloscope and an arbitrary function generator to show you more trigger techniques. They'll come in handy for capturing digital signals in bursts. I'll use waveforms out of the generator to show you how to use pulse width triggering, show more uses for trigger hold-off, and explain how to use Runt pulse triggers. There will be times when edge triggering just doesn't cut it, and it doesn't let you see what you're looking for. When you're dealing with signals of changing frequency or pulses of changing width, edge triggering isn't very effective. You can think of digital signals as streams of pulses with lots of different widths. When you're analyzing digital systems, you're looking for things like the start of a digital communications packet, missing pulses, or pulses that are the wrong shape. Pulse width triggering comes in handy for capturing these events by triggering the oscilloscope on a positive or negative pulse of a duration you specify. Let's look at a couple of examples. To use pulse width triggering, you specify the kind of pulse you're looking for. It uses a single level to define the difference between high and low, so I'll set that about midway. Now let's look for a positive pulse that equals 100 nanoseconds long. Got it. Now let's look for a pulse that's less than 130 nanoseconds. There it is. It's the same pulse. Let's say you want to find a missing cycle in a clock signal. In this case, we want to trigger on the lack of a pulse. I'll set the polarity to negative and tell the scope to trigger when the negative pulse is greater than half the clock period. In this case, about 108 nanoseconds. The scope triggers right at the missing pulse. On communication buses, you'll see a lot of clocks that come in bursts. Here's a 100 kilohertz clock that comes in bursts every 200 microseconds. Pulse width triggering can be used for this too. The clock period is 10 microseconds, and the positive part of the clock is 5 microseconds. So we'll look for the dead time at the front of the burst by setting the pulse width trigger for a negative pulse greater than 10 microseconds or so. As you can see, the scope triggers just before the clock burst. Another way to trigger on digital or analog bursts is to use our old friend edge triggering with trigger hold-off. I'll set the hold-off control to hold off the trigger for the duration of the 100 microsecond clock burst. This approach also triggers the scope on the dead time before the burst. Now let's move on to Runt triggering. First, I'd better explain what we mean by a Runt pulse. Sometimes in digital circuits, pulses don't reach a valid high or low level. This might be because of switching between asynchronous clocks or a metastable output of a flip-flop. The resulting stunted pulses are called runts. Pulse width and edge triggering can't single out runts. Runt triggering uses two thresholds, and it looks for pulses that pass through one threshold, but not the other. For Runt trigger type, you need to specify the polarity of the pulse you're looking for, the two threshold levels, and whether you want the scope to trigger on any runt or on a runt of a particular width. Now let's capture a positive runt. The polarity is already set to positive. I'll set the threshold to plus 800 millivolts and minus 800 millivolts. I'll leave the trigger when setting to trigger on any runt. And there's our runt. So that's it for our advanced triggering tutorial. I showed how pulse width and Runt triggers can help capture digital anomalies, and we took a second look at trigger hold-off. In the next video, we'll look at basic time and amplitude measurements by reading off the display or using cursors. Thanks for watching.
Find out more at Vicom's website.